y equals 1 over x e to the 2x. Let's have a look at this then. Let's just sketch in these constituent parts. The 1 over x curve, when x is 0, it shoots off to infinity, doesn't it? So the 1 over x we know looks like, customarily, looks like this, and shoots off to 0 that side. And on the negative side we know it shoots off like so on the negative side. There's our 1 over x curve, which we've seen before. E to the 2x, so when x is 0 we've got the value 1, and e to the 2x shoots up to infinity here and comes down and stays positive but tends to 0 really quickly. So there's our exponential. Now we want the product. The first thing to notice is there's two positives in this quadrant, so we're over here in this quadrant for positives. Negatives, we've got two different signs, so we're on the negative side. As x gets large negative, we can see we've got the product of two very small numbers, so it's going to be here. As x gets large positive, it's going to shoot up, isn't it, to infinity, because this will dominate the e to the x. If you put in 100, say you get 1 over 100 times e to the 200, it's going to still shoot up really large. So let's get y dash then to see where the turning points are. So it's a product, so it's u times the v dx, which is a function of a function, e to the something differentiates to e to the something, multiplied by the something differentiated, plus v, and then the u dx, and this is x to the minus 1 in your mind's eye, so it's minus 1 over x squared, isn't it? Let that equal 0. What have we got common here? We've got an e to the 2x we can take out, and we can take out an x, and then we're left with a 2 here, minus 1 over x equals 0. That tells us that x needs to be a half for that to equal 0. So we have a turning point at a half. When x is 0, it's not defined. Now when x is 0, it shoots off to infinity, doesn't it? Because this will tend to infinity, and this will just tend to 1. So we're going to be up here. So it's going to come down here, and it's going to end up going back up there really quickly. Okay, so it's going to come down to a minimum at a half. When x is a half, we get 2e to the 1, don't we? 2e to the 1 is going to be up here somewhere. So 2e is just here, and so we can draw this side of the curve in now. It comes down, sweeps down to a minimum, and then swings back up like so, a bit quicker than that actually. So it comes down here, swings down to the minimum, and then swings back up nice and quickly. Now on the negative side, if we look just small negatives, we get numbers about 1, but this is very large here, so it's going to tend towards infinity again, isn't it? And then we're going to come up from here. Now it's going to tend towards this value here, but it's going to do it, these numbers here in the product here are all less than 1, so it's going to come down rather much more quickly than this thing. So I'm not going to be able to sketch it accurately because otherwise I'll have nothing to draw, but I'm just going to follow that line, which is nice and low anyway. Okay, so I think that's what we've got then. There's no other turning points, so it doesn't kick back or anything, and that's what we've got there. So let's have a look at the widget. 1 over x e to the 2x then. 1 divided by x times e to the power bracket 2x close bracket. Let's see if it's interpreted that correctly. We'll do from minus 3 say to 3. We'll probably have to change that in a moment. 1 over x e to the 2x, it's got it correctly, and we can see the essence of the curve, can't we? Yeah. The minimum, yeah, that was fine. Good.